Hi, I will start with the tutorial. So I implemented 8.FFT. So for that, I will start from normal 8.FFT and then we can go to multicycle 8.FFT. So this is the project for 8.FFT. So this is the project for 8.FFT. So I will start again. This is the first I will explain you the 8.FFT project. Then I can go to the multi-cycle 8.FFT. So this is the FFT8 program, and for this we have first generated FFT package. In FFT package, what we have done is we have described one type, that is complex. Complex is a real and imaginary part that is of 15 down to 0, and then we have initialized type comp array is array of 0 to 7 of complex, and type comp array 2 is array 0 to 3 of complex. Then we have described the function add, subtraction and multiplication. After that, this is the package body where we have implemented the packages. This is the add. uh, This is the definition of add package, definition of subtraction package, and definition of multiplication package. So addition and subtraction as usual. We have adding the real numbers to real numbers and imaginary numbers to imaginary numbers. Here subtraction is also same, but in the multiplication we do this thing. First thing we have to know, we need to know is it is since we are multiplicating and it is a floating point, so we kept 8 point for fractional part and 8 point for multi integer part. So when we are multiplying n1 dot r into n2 dot r minus n1 dot I into n2 dot I, so n1 dot r into n2 dot r has it will get 16 integer point and 16 points for integer and 16 point for fraction. So from that we will take only 8 point for integer and 8 point for fraction, that we will do from 23 down to 8. Otherwise it will be a 32-bit number, but we will discard them and we will take only 23 down to 8 numbers. So this is the main thing in the FFT part, that is multiplication. Then we have done this butterfly algorithm. Here in butterfly, what we do is we are just implementing what does butterfly do. So it usually do is S1 plus S2 multiplication with W, and then this is the task. Here we taken 2 3 cases, and just for checking it, I have taken 2 3 cases and then I have generalized it to 1 case. So now I will now open model sim. For model sim, this is the FFT8 program where we are sending the S input as a comp array, that is I have already defined comp array is array 0 to 7 of complex, array 0 to 7 of complex. So we have FFT at S5. Both are array 0 to 7 of complex. Complex is 16 bit. 16. Then we are initializing this component, butterfly component. Then G1, G2 are the signals uh, in between the stages. This is the first stage. This is the second stage, and this is the third. In the first stage, we take S0, S4, generate C1, 0, C1, 1, then S2, S6, generate C1, 2, 3. Then these are the intermediate values. Similarly, these are the intermediate values. After getting two intermediate values, we will be able to find the final value, that is Y0 to Y. So the output is coming. If you want to check the output, I have given the input as 0, 1, 2, 3, 4, 5, 6, 7. And for this output as comes as 128 in the first part, that is 0, 1, 2, 3, 4, 5. 1, 2, 4, 8, and 16. In 4, 20 and 8.28. So if you check these outputs, they are similar. That is, these are coming in -4, -4, -4, -4, -4, -4, -4. And these are coming in decimal value plus 4 point something, plus 4 point something, like this. You can check that these are matching with the actual output value. Now we will go for the multi-cycle point FFT. So here only thing we have changed is we have introduced the clock, reset, start and done. So we have defined the three stages, SP0, SP1, SP2, and SP reset, SP start, SP done. So these are 1, 2, 3, 4, 5, 6 stages. So this is the program when we are going to a FSM machine. So when the reset is 0, we remain in the SP reset state. And then we need, if it is not, then we initialize done as 0, and then we go for the cases. And these cases are as ST reset. If we are in ST reset state, then we check if start is 1, then we go to the start state. If we are in start state, initialize T1, that is intermediate values for after the first stage. We initialize them, and we uh, we send the present state to the ST0 state. That is the first computation of butterfly. So in the ST0, we do the butterfly computation, and T1 also we do the butterfly computation. In ST1 also we do the butterfly computation. In T2 also we do the butterfly computation and got the answer. So we are doing the butterfly computation in T0, T1. In ST2 we complete the state, and also we initialize done in the ST2 only. Since this is a signal, we get initialized in the block. So its state test case will also be different. So here also we have to initialize the clock with the start and end, then we have to map them to the entity, and then we do the same thing. Then we give the input after initializing clock. This screen is fluctuating with the time using the end test. Is my probe. It is my team is on the test. Here we get the output after these are the inputs, these are the outputs. So we start getting output after this stage. we can check all the units. Here we can say option. Here it is.